You're probably familiar with the three states of matter: gas, liquid, and solid. How is it they differ from each other? They basically differ in the amount of kinetic energy, so how fast the molecules are moving. Gas is fastest, solid is slowest, and how closely they are, how close the molecules are together. Gas extremely far apart, liquid very close, solid the closest of all. So what you see is free, crazy movement in a gas. In a liquid, the molecules are still moving freely, but they don't leave each other. In a solid, the molecules are held in place and the movement is just jiggling in place, basically. There are two types of energy changes. You can either have a physical change or a chemical change, and we briefly discussed that earlier. What's happening in a physical change? You have a phase change. You go from gas to liquid or whatever. And what causes that is that the molecule speeds are changing. In a chemical change, you have molecules change. Bonds break and bonds form, and the bond energy changes. There are two types of energy changes, and it's in both phase changes and chemical changes. When energy is absorbed by a molecule, it's called an endothermic reaction, and it can either be in a phase change or a chemical change. Energy released is called exothermic. So in a physical change, the energy is actually going from one place to another. An example is there's warm air melting ice. The air energy is being transferred to the ice energy. So the ice has faster molecules and it goes from solid to liquid. And the air gets cooler. That's exothermic for the air, it's giving up its energy, and endothermic for the ice. Now, if we have a chemical change, an example is alcohol burning. Someone lights alcohol and it starts burning with a flame. What's happening there is a chemical change. The alcohol is changing from alcohol to carbon dioxide and water. This fire releases heat. It's going from the inside of the molecules where the bonds are to the outside, so we call it exothermic. Heat is coming from the bonds, so the bond energy drops. So what you have is alcohol with high bond energy, and then carbon dioxide and water having low bond energy. In phase changes, you're just having a change in the speed of the molecules, and there are names for the different phase changes. Here is a solid, a liquid, and a gas. What happens in melting, you're probably really familiar with this, that solid changes to a liquid because the molecules are speeding up. They have to absorb energy, so it's endothermic. In freezing, you're taking it from liquid to solid, and so you have to take energy out. That's exothermic. In vaporization, we go from liquid to gas because you have to speed up the molecules. You've got to put energy in. That's endothermic. In condensation, we go from gas to liquid. You've got to take energy out in order for it to condense. Exothermic. Sublimation is a solid going directly to a gas because it speeds up the energy of the molecules. That's endothermic. Deposition is when a gas turns to a solid. You have to take energy out to make it do that, so it's exothermic. And this idea can sometimes be confusing because people think about the temperature rather than what's happening with the molecules. In melting, of course, it's getting warmer, so you think exothermic, but it's actually the opposite. Now, when a reaction does a change, it's different. In a reaction, we're looking at bond energy changing to molecule movement and vice versa. So when energy goes into a molecule bond, the molecule's slow and the temperature is lower. That's endothermic. When energy comes out of bonds, molecules speed up and the temperature is higher, exothermic. So you can see there's a difference between phase changes and chemical changes in the temperature reaction to the change. Well, let's look at the energy in reactions. When we're looking at a reaction, old bonds are breaking and new bonds are forming. Breaking bonds sucks energy in, and making bonds puts energy out. So when we look at a change in a chemical reaction, an energy change in a chemical reaction, there's usually a difference between the reactants and the products. And we call the difference in energy the enthalpy of reaction. The enthalpy of reaction can be either exothermic or endothermic. As I said, if it gives off heat to the surroundings, then it's exothermic, and if it takes in heat, then it's endothermic. Here's an example of heat being given off. You can take propane and burn it, and you make carbon dioxide and water plus heat. This is exothermic. The temperature rises, the bond energy drops. So here is what we call a reaction profile for this. So what we're showing is the potential energy that is stored in the bonds here. The reactants have a higher energy, the products have a lower energy. Now, if you have propane and oxygen mixed together, they just don't react unless there's a little spark of energy given. That's because every reaction has something called an activation energy. The activation energy is the energy to break bonds before new bonds form. And so this energy is what is needed from here to here, is called the activation energy. And every reaction has this, and this keeps reactions from just going on completely. And I mean, there's a little control in things because of the activation energy. Now, the enthalpy of reaction is actually the change in energy from the reactants to the products. This is an exothermic reaction because you see energy is going out of the molecules, the molecule energy is dropping, and so it's released as movement of the molecules. Potential energy drops, kinetic energy goes up. And there's a change in the bond strength of the molecules. When you have heat taken in, it's written like this: heat plus something. This is solid ammonium chloride. You dissolve it in water, and what do you get? You actually get ions floating around in solution. We'll look at this later on in a later chapter in more detail. But just suffice to see that heat is being taken away. You don't have this heat anymore. It's been put into the molecules over here. This is endothermic because heat is being taken out and changed to bond energy. The temperature drops and the potential energy of the molecules rises. Here's a reaction profile for that. Here's the ammonium chloride as a solid, and here is the ammonium and chloride ions in solution. We're going up in energy. This too has an activation energy. Here's the activation energy. Bonds have to be broken before new bonds form. That's the activation energy always from the reactant to the top of the curve. The enthalpy of reaction, the heat absorbed or released, is always going to be the difference between the reactants and the products. Notice we're looking at potential energy here. Potential energy is going up, so kinetic energy is going down. That means this gets colder. This is a reaction that we see in the cold packs that they use, let's say for a sports injury, and you break something inside a plastic package that's kind of mushy, and you can put it on a sprained ankle or something like that. What's happening is an endothermic reaction, and the pack starts getting cold.